Good day to you. This is Anagalactic bringing you our conjugate series. We've been preparing for this for a long time. This will be pure geometry. Now you should know that I'm preparing a more complete lecture series that will cover this topic as well as the other topics we've been covering, but with diagrams. This, after all, is video, and in this presentation, which should be brief, you'll simply be seeing my pretty face. And I'm sorry about that, because I should have over here a diagram, which then can be switched to new screens. And I'm preparing that. But for now, this will be adequate just to relate to you the broad topic we're going to be covering. Broad in the sense that it's synthetic. What I deal with is extremely basic material. The very number system itself, the meaning of 0, 1, and 2, the way we split numbers, the way we use various dimensional systems, imaginarity, infinity, these are extremely basic issues. The Planck length, the speed of light, my goodness. Well, it is important to have a thorough grasp of the totality. That is, where are we at? At any point in history, it's somewhat abstract, but there is a threshold which science has reached. Obviously, science has advanced further than it had been able to advance 400 years ago or 2,000 years ago. But can you do it? I can assure you, I hope your answer is no, you can't, because you can't. Nobody can. The physicists can't. It's fractalized. It's fractalized because science ran head-on at light speed into a black hole and can't get out now. Well, there is a way out, though. So, conjugation. First of all, that does sound like a learned term, like that's not really basic at all. That's only for those white smocks and PhDs to handle. That's not for ordinary mortals. Oh my goodness, nothing could be further from the truth. The physicists have no conception of conjugation, except in complex mathematics, which is a mistake. So I want to show you the true basis of physical dynamics, beginning with a geometric model that is adequate to the situation, that is, that sums the data that we have into comprehensible form. The current status of science is so miraculously horrible that words can't describe it. Just the calculus textbooks tell someone who knows what they're looking at that something went horrendously wrong. There's no reason to use complex algebra, and there's no reason to use the calculus. These are symptoms of a deep, deep misunderstanding of physics, and of geometry, and of mathematics, and of numbers, and of measurement. All of this has risen to the surface, and now it's caused a form of psychosis. So conjugation is actually what's being missed. So I hope that adequately introduces this topic so that you take it seriously, not ever having heard anybody talk about it. Conjugation. What is it? There are several ways of approaching the topic of conjugation because it's transdisciplinary. It has a very specific meaning in mathematics, but it depends on the context because conjugation has to do essentially today with complex algebra. The translator for complex numbers back to linear numbers is a conjugation operation. So that's really, your exposure to the word would normally be only to that extent of something to do with complex algebra. That's not the way that I use the term, because the correct use of the term conjugation must be reserved for its true classificational usage. And the complex form of conjugation is a very specific application of the principle. And I will cover that, but it's ancillary to what we actually want to know, which is what is conjugation generally, of which complex conjugation is an example. What is it? In the diagram that will be here eventually, I would be able to show you two very simple indexed numbers, a numeric representation. The first one would be what is called a 1D matrix of two components. This would be one number, comma, another number that have a relationship. That comma means that they're related. In the complex number system, that comma means conjugate. So the real component and the imaginary component conjugate. That's their relationship between those two coefficients. So that's the simplest form of conjugation with which we're possibly familiar if you got that far in mathematics. It's usually part of Algebra 2, we called it, which is just before calculus. So it's not calculus, but it's necessary to understand. It's considered in our educational system as a prerequisite to going on to calculus, which is deadly. And you do not want to ever take a calculus course because it'll hurt your mind. It'll actually steer you in the wrong way of thinking. So conjugation in the geometric sense is by far the most important, and that is ordinarily where I would begin. But when broadcasting to a general audience, you don't have the background that I have to know that the geometric definition of conjugation is the king. That's at the top. But we need to start one level down with numeric conjugation, because essentially this is a shortcut for you to understand what I understand. That is the purpose of a science presentation, is to pass along understanding. So to do that, there must be a meeting of minds, and I have some background that I've shared over 700 videos, that is over the span of about 700 videos now, to provide that background. But it's very unlikely that you have time to review those. So my job is to make things simple, and this is the course that I've chosen for presenting conjugation. Not with the geometric definition first, but that's what we'll close with. So mathematical conjugation begins with the realization that there are two levels of mathematical identity. That is, what makes mathematics consistent consists in two identity numbers. This is quite basic. The additive identity is 0. And as I've proved, and you can accept this now if you haven't heard my prior lectures, 0 is the balance number of the line, and that's its only reason for existence. 0 is a very peculiar number, and it's caused a lot of problems. I have the solution to that, so that's what we're leading up to. What was overlooked by all mathematicians ever since the beginning of time is, and this is a remarkable thing to say, but I have to say it forthrightly because I've proved that it's true. The other identity number is 1, but it's not the identity number for the line. So there are two identity numbers. All mathematicians understand this, so I'm just stating, as must be done in a scientific presentation, the obvious first. So we all begin with the same foundation. Now, so there are two identity numbers. Now, what has been known since, you could say, the time of Euclid, and I'll just leave it at that, we have known about the Archimedean, which is the identity of the line. The identity number is the Archimedean of the number system. But the geometric equivalent of that is called the Archimedean, which is not a numeric term. So Archimedean and identity should be expanded to two-word terms. You shouldn't just say a one-word term if you can say a two-word term that's more specific, because it'll avoid confusion. So the right way to say that is, there is an additive identity that is 0, and the object to which it applies is the line, which has an Archimedean called the center. So the Archimedean center is the same thing as linear 0. So we all know that, and that's where we begin, because now we go up a step. What about the Archimedean of 1? That would be the Archimedean of another object. That's a hypothesis, but I've proved it, so I'm leading you through the steps. It's quite obvious once you see it. So I hope you pay attention, because this is a real turning point in scientific understanding for anyone who gets this. It's never been taught. You're hearing it for the first time. So, the numeric center of the line is 0, but 1 is not associated with an object. 0 is associated with the line. But 1, which is the multiplicative identity, is not associated with an object. So it's not an Archimedean of any object. The center point is the Archimedean of the line. But 1 has never been considered an Archimedean of any object. But it could be, because there's only one other object, the circle. And so I investigated the possibility of assigning a number to the circle, which would make the circumference of the unit circle 1. The term, which is a compound of two words, the term unit circle already has a definition. It's the circle that is composed on radius 1. Well, we don't want that. That's really the whole point of the hypothesis. We want to start a number system, if possible, that does not have an Archimedean of 0. It has an Archimedean of 1. And since there's only one object to which that might apply, we apply it to the circumference of the circle, which means that the radius is 1 over tau. And you know that, so I hope you know that. You could, I don't have time to go into that, but the radius is now a linear number tau, except it's irrational. So the radius is irrational in order to make the circumference rational. So we do have a link. That proves that linear algebra is embedded in circular space, and that's the right way to say it, and I did prove that. So it's very important that you accept my proof. That is, that you examine it and make sure that you can prove it to someone else. That's called science. So I have done that, so you will accept that. Now, once you do that, you're left with a circle and a number. If it were the line, you would have a line and a 0. Correct? Well, here you have a circle that is the 1. So the numbers on the line range from 0 in two directions, correct? You could say so. If it's the diameter of a circle in embedding space, then the center is 0. But in this system, the center is 1, which doesn't really make sense. And so I need to talk about that for just a moment, because this leads directly into the proof for what is conjugation. What is it actually? Now, let's just pause here, because I want to switch tacks a little bit. We have a circle that has a value of 1, and that doesn't mean anything. I just said it, and you could say that, so the circle has the value of 1, so what? All right. First of all, we need to compare the circle with the line, because the line has the additive identity at the center, correct? What we're saying is the circle has the multiplicative identity at the center of its number system, which means that all the numbers are similar to or relate to the circle itself, which is not a line. Well, what is it? It's a closed line. And that's an incorrect term. And the reason we're forced to use an incorrect term, which I balk at, but I'm expressing to you the dilemma that a classification expert faces when facing the legacy of human stupidity. And this is me facing that problem, that I've inherited a problem from my stupid ancestors, who, since they didn't know anything else, started out by calling a straight line a line, but now there's no word for the circle. So what people say now, and it's become conventionalized, it's a curved line. You can do much better than that, and you must do much better than that, because it's not a line. The circle is not a line, and you can't say that the circle has anything in common with a line. It has nothing in common with a line. They have no similarities whatsoever. They're absolutely separate objects. Because the straight line is peculiar. The universe is curved. And it contains what we would call a very special curve that has no curvature. It's a curve that has no curvature. That's the right way to define a line. A line is an extremely limited object in comparison with curvature, because the entire universe is made of curvature, and it's not at all made of lines. So we use lines simply because that has the number system on it. So what we need is a number system that extends linear numbers to two-component space. And to do that, you have to master the subject of conjugation. Fortunately, we have an excellent example of how to do conjugation. The complex number system is an excellent tool. Although I pillory it and throw mud at it and kick it whenever I can, it has a very specific usage as a tool. The reason I kick it around is because that tool needs to stay where it's used. It's not a general tool. It doesn't provide general understanding unless you know what I know, so let me explain to you why the complex number system is used exclusively now, which is really bad. It's a very bad decision that physicists have decided that they need complex numbers. Now, physicists don't need complex numbers. The people who need complex numbers are called engineers. Engineers need complex numbers. Complex numbers are extremely useful, for instance, in electrical engineering, but they're also used in all forms of engineering. They go right along with the calculus, because we need tools to get at curvature. Well, there's a much better answer to that nobody ever thought of. What if you had a number system for curvature? Well, if you did, you would need to be sure that it worked on the circle. And in fact, that is what you do. You develop a number system for the circle. That's what I did. But in order to do that, you need to be able to recover the linear numbers, because they're computable. Complex numbers are not computable. And by definition, spherical numbers are not computable for the same reason. So you need the translator. For complex number transformation back to linear numbers, it's called the conjugate translator. And it's quite simple, really. It's a matrix. It's a 2x2 matrix. And you just cross multiply and it gets rid of I. Because when you multiply a number that's associated with I by another number that's associated with I, you know that I and I multiply to -1. So the two numbers that have the I axis, that is the I orthogonal basis axis is what it's called, they don't have the index of 1, they have the index of I. And the index of I, of course, is a very strange number. But but it's an important number because it gives you access to curvature because you're using a matrix now. On the line, if you composed a matrix for two component numbers on the line, it would begin at 0, 0. And the first number would be 1, negative 1 because it adds to 0. And the next number would be 2, negative 2 because they add to 0. So the translator is add. And there's no change, there's no axis, it's just the line. So it's very simple. That's called it could be called a simple matrix, but really all it is two numbers with an association. In this case, they add to 0. So that would be the matrix for the line. Well, you can make a matrix for the circle. And if you use I is on one of the diagonals, and the other diagonal is the real numbers. So you cross multiply the real numbers on one diagonal, and you cross multiply the I numbers on the other diagonal, and you get rid of I. And you get two numbers that amount to X and Y. It's really useful because the I, since it's the square root of negative 1, simulates a rotation on a circle. But it is simulated. You still need calculus. There's no way around that. So you need calculus with complex numbers. Very few men have ever mastered that. You have to be bred for it. You have to be bred by your educational system. It's a form of natural selection. In fact, it's the only form of natural selection. So the only form of natural selection is completely unnatural. It's designed to produce mathematicians and engineers for the government. All mathematicians work for a government. Mathematicians never work independently. They're sponsored by some government. That's what a mathematician does. It's a government slave. So that's your mathematician big boy club. Oh, they're very proud of their work. And it shows, Daddy-o. Monsters. Absolutely miscreant monsters. Well, that's what breeding does. So, I'm sorry about that little divagation, but I do have quite a bit of emotional constitution invested in this. So to go on to our conjugation, instead of having I on one diagonal, you have 1. I discovered that. The greatest discovery in the history of mathematics is that discovery that I made. Is that you replace the complex I with unity. And then you need to use your head, of course. So I've proved all this, but it's really, really simple. You can parameterize the circle on two conjugate numbers. I discovered that. You can parameterize the line on two conjugate numbers, except they're polaric. So it's plus and minus. But on the circle, it's multiply and divide. Multiply goes out from the surface of the circle, and divide goes in. Interesting, yes? So let's see how that works so we can develop our new number system on conjugation so I can show you the geometry. When you have a circle that has a unit value, which is my discovery, nobody has ever tried this. You assign the number 1 proportion 1. That's 1 over 1, so that's division. So the value of the surface of the circle is 1 proportion 1. We write that as 1 over 1, which reduces to linear 1, but it's not a linear form. And the reason it's not a linear form is because you need conjugation. This is my discovery. It's fantastic. It's the greatest, most exciting discovery in the history of science. So I hope you enjoy this. Once you realize that the surface number for the circle is 1 over 1, you can now form a coherent number system for universal space that is better than the linear number system, because it is the linear number system raised to a power. That's not strictly speaking true, because you know what a power is, but it's raising it to a higher space. And that is the right way to say it, although you'd have to know what is meant by space. It does have to do with spatial space, though, which the line, by the way, only offers the function of distance in space. The line can only compute distance, but Albert Einstein proved that that's an illusion. That every distance has another number that's not the distance. It's the event. It's the event. Because you know the event on the star is not the same as the event at your telescope. There's a light year span. That's actual time. There's a time lag. So that's called event space. So now you need to conjugate event space with spatial space, because Albert Einstein proved that conjugate space is perpendicular, and there's the secret. This is what Albert Einstein discovered. He discovered that there's an element that can be linearized in event space, and he called it time, and we've called it time ever since. But I've shown you what time is, and if you haven't seen those videos, it's okay, because I'll show you again now. It's not exactly time. We're getting two derivative numbers from the universe that need to be conjugated into the universal number system, but not using complexity. I'll show you how I got complexity into the system. There's a reason we use imaginary space. The imaginary component of the complex number is well named. And I'll show you where that actual imaginary space is right now. So we have a surface called a circle, and it's not the inside, and it's not the outside. That's where the numbers go. So we're going to be able to parameterize the circle using conjugation on rational numbers. For this system to work, there can be no zero, and in fact there is no zero. You might ask, where did zero go? Hold that thought. Hold that thought. It's there. There is still a zero at the center of the circle. There definitely is. You know why? Because you can draw a line through the center. And since you can draw a line through the center, zero is at the center of that line. But it's not at the center of the circle. Do you know why? It's because the circle is the center. And that's a redefinition of center. We always think of the center as the Euclidean null. The Euclidean null point. Actually, that's a phantasm. There's no such thing as a null point or number in the universe. Zero does not exist, and Euclid's null point is only useful for linear add. It only works with add. That's why it works so well for distance, because distance is strictly positive and only uses add. You simply use the index and repeat it until you get to the star. And that comes out to a certain number of meters. It's a very large number, but it's precise. Linear mathematics is precise inside the system of add, but you cannot use multiply or divide. Those do not work. They don't work in the linear system. So why were we taught multiplication and division? Because nobody saw what I saw. Is that the linear number system is the derivative number system of the actual number system. They work together. They have to work together because the computable numbers are linear. And the reason they do work is because you can draw a line through the center of the circle. But the center of the circle is not linear. The circle itself is the center of the system. And what it does is it relates the inside to the outside. Well, you need conjugation to do that. Here's how you do it. You use what is called inversive geometry. I discovered this on my own, that my system has been in use already. So I would be going out on a limb to say I discovered this system. Oh, yes, I did. The inversive geometry experts, among whom is Zvezdelina Stankova, and you can see her out on the internet. You've got to see it. It's unbelievable, and you may get addicted to inversive geometry because it's fun and it's simple, but it uses an unfamiliar space. It's circular space, and here's how you do it. First of all, you have your circle. Now, in inversive geometry, I have not seen yet that the circle has been given a number. Nobody's ever done that. So inversive geometry simply shows an aspect of what I've done. So here's how you do it. You can say that the circle is 1 and it still works. But when you do make the circle 1, that is, the circumference has a value of 1 over 1. 1 proportion 1. Well, that relates two quantities together. What two quantities? The inside and the outside. So here's how you do it. It doesn't make sense in linear space, but it makes definitional sense in circular space. Because as you go from the surface in, it gets smaller and smaller, right? But if you go out from the surface of the circle, it gets bigger and bigger. Well, the proportion between the two numbers, which would begin at 2 1/2, right? And then 4 1/4, and then 8 1/8, and then infinity over 1, 1 over infinity. 1 over infinity is the center, and infinity over 1 is the edge. There can be no 0 because the system is based on 1. So technically there are no numbers less than 1. So what we call 1/2, these would be, I call them the unit fractions. It's when 1 is in the numerator and a whole number is in the denominator. Max Planck proved that physics supports that. So this is actually directly addressing modern physics. And you'll see that in a moment. So now you have the surface value, a two-component number that is 1 proportion 1, but what's the relator? What's the relationship between the two numbers? In complex formulation, the relationship between the two numbers is a conjugate matrix. That translates the numbers back to linear form. You start with two numbers and you end up with two numbers. It's the same thing in spherical space. You get two linear numbers back from spherical number space. The same way you get two linear numbers back from complex number space using the translator. So the translator is critical. Otherwise it doesn't work. Conjugate algebra does work for the complex number system because it's simple cross multiplication. So it does use the multiplicative identity, except it uses it on I, which translates I basically to negative linear space. So that is consistent, we think. In this system, all numbers are positive, which matches physics again. There actually are no negative numbers. Although you can use that negative positive system, that's polaric. Negative and positive are 180 degrees. Well, you might be able to guess now what conjugation does. It translates it translates between two relators. It's a little technical, but I'll explain it. Don't worry. I'm just giving you, this is how I roll, okay? So try to pay attention. So the two numbers that parameterize the circle are two multiplicatively inverse numbers. And we know now from discoveries in physics that those are whole numbers. All the numbers, all four numbers in the matrix are whole numbers. And on one diagonal is not I, it's 1. Which means that all the numbers are positive. The reason I was chosen is because it actually gives you access to negative number space, which the universe does not use, but in linear space we're forced to use it because the line is half negative. Well, in circular space there is no negativity because there is no 0. 0 is what divides the polaric line, plus and minus. That's obvious. But in conjugate space, it's not polaric. It's not polarized. You don't have two antipodes on a line. Instead, you have the center and the edge. And those are the two relators. That, I should say, those are the two basis axes. for linear space, you have an axial system of straight lines, but in circular space you have no such thing. Instead, what you have is an integral line that comes out from the center. If it's gravity, it pulls in toward the center. And so that's consistent. That's a straight line. What I'm doing, expanding spherically, that's a straight line, of which a linear straight line is the derivative. It's the infinitesimal of the surface. It's the infinitesimal of the force line, and it is a force. That expresses the situation perfectly. This overturns Newtonian mechanics, but not so as to destroy it. We know that Newtonian mechanics works in certain context, but we need now the full integral solution so we can get universal space. Newtonian space is only useful in a local system. It has to be very confined, such as the solar system. Then it works, because you use calculus. Oh, we're not going to use calculus, because the purpose of the calculus is to artificially translate curvature to linearity. So you know that already. That's basic calculus. It starts with a curve to translate it to a linear number. That's called a rate, and it's actually a two-component number. So mathematics is just really in a trap, And the way out of that trap, so you don't have to use the square root of -1, and you don't have to use calculus where you throw out a delta, then what you need to do is integrate your number system so that it's rational. And that seems obvious, but nobody ever thought of doing it. Nobody knew how. I know how, so this is how to do it. You rationalize your entire number system by integrating it into a two-component number system. That gets rid of 0, and it gets rid of the negative numbers. Now, everything now depends on if you can show some use, some value in computing, I say spherical space or circular space. We're starting with a circle, but everything we say about the circle is directly translatable to the sphere, and I have proved that, so don't worry. So when I say circle or sphere, I very often interchange them. It bugs even me, and if it bugs you, I'm sorry. But the circle and the sphere are identical on a 2-to-1 relationship. You can accept that because I've proved it. So that's why I say circle and sphere sometimes interchangeably. Don't worry if I do, because they mean the same thing. All right? For the same reason that pi and tau are the same thing, because there's a 2-to-1 relationship between pi and tau. Well, there's a 2-to-1 relationship between the circle and the sphere. That's extraordinarily profound, but that's beyond your level right now. I just wanted to throw in a hint. This goes beyond anything anybody's ever thought of before. Because it's synthetic, it's integrative, it provides understanding, it solves paradoxes, and it solves problems, a lot of them. So this is monumentally profound. So the conjugation is actually orthogonality. Instead of a polaric relation on add, when you switch to the multiplicative identity, the relator between the two component numbers is orthogonality, and I'll show that to you now. Remember, here's the force line. Now, we're in spherical space now. But this also, let's do the circle. If you draw just a radius, you're drawing a derivative of circular space. Because the radius is actually anywhere. You like dial the radius anywhere. Well, if you take the integral, you have the pressure. You have the force line. And it is a line. And it's the true line. The line that we call the line is not the true line. The true line is this line. It's a ray. Because it has to be positive. There are no negative numbers. So you can't use the line. You have to use the line. You can't use the line. You have to use the line. And the difference between the line sub 1 and the line sub 2 is that the line sub 1 is the derivative, the calculus derivative of the line sub 2. Well, when you switch to two-component space, you're using the integral. And that's the line. That's the line sub 2. So we've changed the definition of line. And now you're going to have to come up with some other name for this straight thing. Just call it a straight. We're not using straights. We're using the universe line. This is the universal line. It's chiral. It has two directions. It either goes in towards the center, that's called gravity, or it goes out from the center, that's called light. And that's centrifugal force and centripetal force. So we're getting there, but this is how you actually can know what those are. And this explains everything, so pay attention. The two-component number system that parameterizes the circle is composed of pairs of numbers that multiply to 1. Now that should make sense to you at this point. If it doesn't, let me just remind you. On the line, all the pairs of numbers add to the center. Here, the circle, or the sphere, is the center. It has an interior and an exterior, but the center of the system is the surface. And the two-componency addresses the inner and outer. But it's not polaric. That's the miraculous insight that I was able to achieve by the blessing of the universe. I have to say this. I could not have thought this up, but I dreamt about it for so long that one night I understood. And then I was able to go forward. This occurred about 3 years ago, more or less. So here's the solution that I found. Is that you have a two-component number that parameterizes the circle. Remember, the two-component number system of the line basically parameterizes the point. It parameterizes null. Everything adds to nothing. And the two infinities add to nothing. In this system, things are not so... Well, you could say a lot of... They're not so... It's not quite as straightforward, but it also is not as naive. And that's the big difference. So instead of adding to 0, these numbers multiply to 1. So to parameterize the space, you need two numbers, not one. On the line, you need one number, and you can only get one number. So it's a one-component number system. That's the line. But in circular space, it has to be two numbers. And they multiply together to make the center on in and out. So the force line is either outward or inward. And those are the only two directions. It's either pulling in as a force or pushing out as a force. If it's pushing out as a force, it's called light propagation. That's the definition of light speed. That is the definition of light speed. We're getting there, don't worry, but I think you understand that this is light speed. That is correct. That's been proved. Huygens proved it, believe it or not. So, we do have a valid system of in and out. It's not left and right. It's not plus and minus. It's in and out. And two-component number system parameterizes the in-out space. But you see, we've only parameterized one dimension. It has two dimensions. It has to, because it has a two-component number system. So what is the other dimension? This is a major insight, so I'm going to repeat this now at the risk of tedium. If this is going out and this is the line, what's the other dimension? It's perpendicular. It's perpendicular. It's not plus minus. It's orthogonal. And that's conjugate algebra. That's a true conjugation. Is when you multiply two numbers, you're not adding them to 0, you're multiplying them to the surface. So to get the surface, you have two numbers. One is inside and one is outside. So that would be 2 over 1 and 1 over 2 is the simplest of those numbers. That's the quantum jump in circular space. That is the quantum jump in spheric space. The quantum jump that we refer to, that Max Planck referred to and we've been referring to ever since, is a linear jump. And that's why it's so baffling is because we're not seeing circular space. The quantum jump does not occur on a line. It's a conjugate jump. And now I think you're starting to see how the pieces fit. This is the origin of the split between one form of mathematics and an integral form of mathematics which is much more powerful because it matches physics. That's what I discovered. The number system for physics. This goes far beyond what Hestinus discovered about the work of Grassmann. Because that's all linear. It's profound, but it's only profound in context of linear perception, which we can no longer use. We must switch to spherical space now. And nobody's even guessed how anyone might do that. Well, I figured it out. So what you do is you begin with the universe's number system, whose lowest number is the center number. And that's always special. 0 is special. It's different from all other numbers because it's the center. Now, on the circle, the same principle holds. That the circle, being 1 proportion 1, is a peculiar number. It's the center, and it has the same relation to circular space or spherical space as the 0 has to linear space because it's the center number. Now, the center number in conjugate space, or we should just say spherical space, the center number is unity. It's the number 1. And so the split is different than it is on the line because on the line you only take one component. You don't say plus 1 minus 1 for a 2-component number. We don't do that. I don't know if anyone's ever thought of doing that, and now I'm curious what that might have implications. If we had a 2-component number system for the line, where every number had a negative component and a positive component, I'm not sure how that would go. But in spherical space, it's very obvious what happens. One number is less than 1, and the other number is greater than 1. However, it's not polaric. It's not plus minus conjugation. It's not plus minus at all because it's not based on add. And there is no 0. There's a 1 at the center of the system, and that is a surface which needs to be parameterized so you have a value for the surface instead of the null point. So that's the difference between linear space, which you can see has a peculiar hole in the middle. Oh, it's causing enormous problems in mathematics at all levels. Always has. But in the spheric number system, there literally is no inconsistency. There's no division by 0 because 0 doesn't exist in circular space. That is in circular mathematics space, which I'm saying is spherical here because we now need to translate this to physics. So the sphere is parameterized on 1 over 2 times 2 over 1. 1 over 2 times 2 over 1 is the smallest number. And Max Planck validated that for physics when he discovered the quantum. That is the quantum. It's that number. Because it jumps from 1. It jumps from 1 in 2 directions. The half goes in and the 2 goes out. And as you get closer and closer to the center, the outer gets closer and closer to infinity. And the outer number never reaches infinity. And the inner number never reaches 0. So the two numbers completely parameterize the space, which now needs to be defined according to the center and the edge. And I've already told you that that works in conjugate space, that you now can compose true imaginary space in its conjugate form. The outside of the visible universe, which we delimit here with a sphere. So the whole universe, say, is a sphere. Well, what's the number at the edge? Well, you know it has to be conjugate with a center in order to multiply to 1. So the center has to be the reciprocal of the edge. That's conjugate. It's also orthogonal, and I'm leading up to that. I'm going to show you true orthogonality, which only occurs in spheric space. Our idea of a right angle is extremely naive and limited. But spherical conjugation, spherical conjugality it could be called, which is spherical orthogonality, is mightily profound, and here's why. When you have a sphere and you make the quantum jump to 2, that's the number going out. You go 2, 4, 8, 16. These are geometric jumps. That can be fine-tuned, don't worry. But there is a jump. Well, there's a jump on the line too. The quantum jump on the line is from 0 to 1. So you get a one-component quantum jump. That's why everyone's baffled. The quantum jump is a conjugate jump in spherical space. Because as the pressure goes out, for instance, generating concentric spheres, you can see it. Concentric spheres are propagated by the whole number component. Because that whole number component is conjugate with a surface on another number. But is that number really inside? It would be if it were polaric. Because it's polaric on any one of the derivative lines. But it's not. Because the mathematics doesn't work. There is no interior. So where's the other number? It's perpendicular. So it's the multiplication of two perpendicular numbers. Therefore, as space propagates in spheric shells, the 1, which is the surface number, is divided on its circumference. So frequency 2 is the dihedron. It's the simplest number on the circle, is 2. Because if you say you put a 1 on the circle, it is the circle. The circle is 1. But it can be divided into fractions. And if you put the frequency 2, you get wavelength 1/2. So therefore, the number on the surface, which changes from 1 to 1/2, is conjugate with a spheric shell. And this has to do with rotation. It's the relationship between the generator of rotation and the generator of space. So space is not conjugate with time, as Albert asserted. Space is not conjugate with time except on a linear derivative where you can fake it. But you're actually not seeing reality. And you're not seeing it correctly, because you're seeing it incompletely. Time is not perpendicular to space. It's not orthogonal. It's not conjugate with it. To force it to conjugation, you need a 3-1 split on the signature. Well, that leads to hypercalculus and madness, which is where we're at. So we want the solution to that so it makes sense and is simple. I, along with Alexander Unziker, believe that science is supposed to be simple. Well, that means mathematics has to be simple. This is the way to get simple mathematics that gives solutions instead of paradoxes. So now we know what light speed is. Because light speed is distance over time. Well, distance is spherical going out. And that's conjugate with rotation, not time. It's conjugate with rotation. And rotation is measured on the sphere. It has to be, because the sphere is what's rotating. So that's actually energy, and it's actually angular momentum. But what it is depends on how you conceptualize it, but it's all of those things. So this is monumentally profound because it gives us a direct insight into what is time. It's not what Albert Einstein said it was. It works in linear space to get space travel, so it's worshipped. Well, that's false worship. You've made a huge, huge blunder by worshipping space-time. And John Archibald Wheeler wrote an entire 150-page poem of adoration, which is normally reserved for deity. So John Wheeler literally lost his mind. Whew! He got a Nobel Prize, but Nobel Prizes don't stop you from losing your mind. That's not the tragedy, though. The tragedy is that he had so much influence on youth. Well, I don't have anything to say about that because I'm not a judge. But in science, you have to be ruthless with these. If someone makes a stupid mistake like that, they must be brought to account, or science can't progress. Now, we're not going to kick his ass or tar and feather him. We'd have to get tens of thousands of these monsters if we were going to do that. No, the whole idea behind science is to break the bounds of darkness. So here's how to do it. It's with conjugation, and we're coming up on an hour, so I'm going to wrap this up. The true number system of the universe is rational, using whole numbers, which are fully computable and solve all the problems in physics. Now, the way to get a grip on that so that you have a sure foundation for your progress in science, and this is the only way to progress, is you have two orthogonal numbers. They're conjugate. That's synonymous. They're also reciprocal. Reciprocal, conjugate, and orthogonal are synonymous in spherical space. That's a mind blower because it's ultimately simplifying. So now you can see what light speed is. It is the sphere. And the entire universe is composed on that relationship of what we call distance over time, but that's the linear form. So when we talk about light speed, we literally are misstating what the universe says. Light does not have a speed. It can't, because speed is distance over time. Light is not distance over time. We think we can compute it that way. We are incorrect. And Alexander Unziker is trying his damnedest to show what I just said. He won't be able to do it unless he has my geometry, which is not mine. I'm just saying it's mine. I say that it's mine because it's not mine, just as the line and the line are two different things. This is why people go mad over this stuff, by the way. Don't look at me, I'm gonna... I may need some water, hold on. So what is it really? Well, you can learn that from the flight of the photon, which explains everything. So here's how to learn conjugate geometry so that you can actually explain the collapse of the wave function. Which, if you can do it, you'll be the first. I will not take credit for this. This is up to you to run with. I'm about to die, okay? Well, not about to die, but we're all about to die. But this is for you. It's not for me. I couldn't care less. I have my reward already. I think you can tell. Well, some call that madness. I call it joy. Whatever. I don't care. But if you really want to progress and do well, whether I'm here or not, here's how you do it. You can explain the collapse of the wave function, which nobody's ever been able to do. And so you just picture the sphere going out. That's light. That's a quantum of light, yes. So it's a particle in superpositional entanglement state. So it's everybody. The particle is everybody on the surface. As all the information is on that sphere, and it's floating out to the edge of the universe. That's what it's doing. It's floating. It's an electron that just lost its atom. It's a part of the electron system that just got detached. And so it's in free fall. That's called centrifugal force, which is another mind blower. So the photon, you can call it a photon, it's perfectly fine as long as you know what you're saying. It is a particle throughout its life cycle. It's emitted as a quantum particle and it floats away in all directions. We say, well, you know now it's not all directions. It's one of two directions. It's going out. So that's centrifugal force. Gravity cannot pull it back. That's centripetal force. It defies gravity. So it's really traveling through a parallel universe. And that is strictly true, except it's not parallel. It's perpendicular. It's traveling through the perpendicular universe that we will never see. Well, I'm showing you how to see it. That thing is definitely going through the parallel universe. You can say parallel, which you shouldn't. You should say orthogonal. It's going through the perpendicular universe, which we can't see because it's the energy domain, not time. It's the energy domain. So that's the definition of energy. So this is a quantum of energy, which is also information. And it's on a sphere floating to the surface in one direction. And when it gets to your eye, it's at your eye. And it's not anywhere else. It's only at your eye. That's the collapse of the wave function. That particle reaches your eye at what looks to be a huge sphere, but it's in a perpendicular dimension. It's not really gaining radius. We think it is because once it hits our eye, we compute the linear distance back to the source. Well, I think you can see that that's why we can't explain the collapse of the wave function. Because that sphere just suddenly disappears to a point, and that defies relativity. Well, that's why relativity is wrong. That disproves relativity. The collapse of the wave function disproves relativity. There's no such thing as general relativity. And I can explain that to you so that you'll actually see it. What Einstein was looking for was the universal frame of reference. Well, there is no such thing, so he couldn't find it. Well, actually, there is such a thing. I found it. But Einstein was looking for what I found, which is the universal frame of reference. Well, you can't get that in one-component number space. There is no universal frame of reference except zero. And zero doesn't actually exist in the universe. We just proved it. So what's the actual reference frame for the universe? Light speed, which is a sphere. Well, that doesn't have a diameter. Of course it does. It's the Planck length. Except it's not the diameter, it's the radius. So the Planck length is the radius of the quantum. And now you can see that the universe has an inner surface. I discovered that as well. It definitely has an inner surface. But when you're trying to measure it through the photon or the electron, you'll never find it. Because the electron doesn't have a center, and neither does the photon. What does have a center is a proton. And the reason we know that is because it makes space. The proton makes a position in space. That's why our linear numbers are so successful with matter, but fail with energy. It's because you can only perceive energy as the conjugate of space. And that's the solution, and that's an hour. I hope you got something out of this. I did. Keep looking up. We'll be back with more, perhaps later today. Otherwise, tomorrow is the equinox. Have a good day. Thank you from Intergalactic.